Hey guys, welcome back. Today we're going to continue learning how we can solve systems of linear equations. So last time we took a look at how to solve them by graphing. That video was just to give you an idea of what exactly a solution to a system is. It was to a point where the graphs of the two lines cross each other. However, the problem with that method is that you don't always get the most accurate answers, especially when you have answers in rational form. And so we have a way of getting more accurate answers. Actually, two different ways. Today we're going to learn one of them. That's called the substitution method. If you have watched my first couple videos, do you remember how I was having to plug in my values of x just to check my equations, like my solutions to my equations? That's what substitution is all about. We use substitution to replace one of the variables to solve for the other. Now, I'm going to show you an example of what this looks like. So I'm going to turn on my equation setting. Let's say you have y equals x plus 3. And then for your second equation, you have x plus 2y equals 6. Alright, so you got two different equations. You got one in standard form and one in slope-intercept form. So how do you solve this system without graphing it? Now don't freak out, because guess what? One of your variables is already solved. Not the constant solved. You cannot take this as part of your solution. But you can substitute this expression x plus 3 for y. Plug it in here and solve for x. So what we do is you take x plus 2 times y is equal to x plus 3 and set it equal to 6. Now we use the distributive property. We get x plus 2 times x is 2x, 2 times 3 is 6, x equals 6. I'm going to do two steps at once here, guys. So we're going to subtract 6 on both sides. 6 minus 6 equals 0. X plus 2x equals 3x. So 3x equals 0. Then really you can just say x equals 0. Simple. Now you might say the solution is 0, x plus 3. However, that is not an acceptable answer. Well, you gotta still find the actual value of y that makes the equation true. It makes the system equations have a solution. So let's say we have y equals 0, because we're substituting for x now. 0 plus 3, and then it just adds up to y equals 3. And then we have our solution: 0, 3. So if you were to graph y equals x plus 3 and x plus 2y equals 6 on a coordinate plane, you would end up having the lines cross at the point 0, 3. Pretty cool, right? Alright. Let's see if you can try one on your own. How about I give you x equals 3y minus 2. And let's see, 3x minus 6 equals negative 2. Does that sound good system to solve? Ooh, no, it's not. 3x minus 6y. Alright, so solve this system of equations using the substitution method. Come back when you're ready. Alright, hopefully you pause the video and try to work this out on your own. And if you're stuck, don't worry, I'm gonna help you. Alright, so we have x equals 3y minus 2, and then 3x minus 6y equals negative 2. We need to find the solution. However, look at this here. We have x equals 3y minus 2. So we can use this and substitute that in for x in this equation right here. So we will end up with 3 times substitute for x, 3y minus 2 minus 6y equals negative 2. And then we use the distributive property. We get 9y minus 6 minus 6y equals negative 2. Again, doing two steps at once here. Combining like terms, we get 3y equals negative 2 plus 6 is 4. And then we happen to get y equals 4/3. And now we can substitute that in for this equation. X equals 3y minus 2. Solve for x. X equals 3 times, 4/3, and minus 2. Now we simplify. 3x equals 3 times 4 equals 12, divided by 3 equals 4, minus 2, which equals 2. And so we get this as our solution. 2 4/3. Alright, so that's how the basic substitution works. Now, I'm going to give you a challenging one. My, this don't look good. We got a situation here. We don't know we have no idea what what one of our variables is equal to. Well, guess what? There's one way to do this by using the substitution method. Alright, so I say we're going to take this equation right here and we're going to solve for x. Notice I'm going to try and solve for x because this is a coefficient of 1, and I'd end up with a positive y value, y coefficient, when it's solved. So we're going to turn this into x equals, we're going to add 2y to both sides. We get 2y minus 2. Alright, so now we can substitute this in for this equation. Don't plug it back into this equation though. You get an odd result. You need to plug this into the equation that you did not use to solve for a variable. So we're going to put this into we substitute for x, 2y minus 2 plus y equals 2. And then we get 3y equals 2 plus 2 equals 4. And then we end up with y equals 4/3 again. And now we solve for x. So I think I'm going to use this equation to solve. So we have x plus substitute for y, 4/3, set it equal to 2. Alright, so 2 is equal to 6/3. 6/3 minus 4/3 equals 2/3. And so we have our solution. Alright, one more. You're going to try this one on your own. Alright. Alright. Try this one on your own. Use the substitution method to find the solution of this system of equations. Pause the video, try to work this out on your own, and then come back. Once you're finished. Alright, so we have 2x minus 3y equals 8, and 4x plus y equals 16. We are asked to find the solution using the substitution method. However, none of our variables are solved for in one of these equations. So what do we have to do? Well, if you take a look here, we have a coefficient of 1 for y. So I say we use this equation right here and solve for y. So we're going to subtract 4x on both sides to make it y equals negative 4x plus 16. Simple. Alright, so now we're going to plug this into this equation. Don't plug it back in, or else you get something called 0x. And you try to divide, you can't divide by 0, can't you? So that's why it's important we have to plug it into an equation that we did not solve for a variable. Okay? Alright, so we have 2x minus 3. Substitute for y, negative 4x plus 16 equals 8. Simplify it with the distributive property. 2x, negative 3 times negative 4 equals positive 12x. And negative 3 times 16 equals negative 48. Set equals 8. Now, we combine like terms, 14x. Set equal to 8 plus 48 equals 56. I have no idea how I got an integer value this time, but I happen to get x equals 4. Yay! Now, we substitute that in for this. Now I'm going to substitute that in for this equation because it's easy to solve for y. So 4 times 4 equals 16. Plus y equals 16. Oh, look at that. The 16s cancel. There you have it. This is our solution to the system. Alright, so hopefully this gave you a pretty good understanding of solving systems of equations with the substitution method. We got one more method to go through. That is called the elimination method. So that will be in the next video. Then in the next video, there's going to be two different things going on. First, I'm going to help you determine which is the best way to solve a system of linear equations. Now I will tell you, don't use the graphing method. Unless you want to do it the hard way, don't graph, okay? Another thing in that video will be that you will find out how there will be special solutions to systems of linear equations. But more on that later. Thanks. For now, you may go on ahead. Be sure to leave a like and subscribe. And if you really like this video, please tell your friends all about this program that I'm doing. Okay? So thanks so much, guys. Have an amazing rest of your day. So long.